Hey guys, this is the day 4 of my Solidity study. So please come with me and continue to learn together on WTF Academy. Today I'm going to cover two courses, I think. Function output and variable data storage and scope. As I consider the content should be okay for me to complete in one day. It won't take too much time. Okay, function output. A Solidity function output include returned variables. So how we can declare it in a function? There are two keywords related to function output: return and returns. The difference is that returns keyword used in the function declaration. It's used to declare the returned variable type and variable name. Return keyword is used in the function body to return something, to return specified variable. So pay more attention here. In the other program languages, we're used to just declare the returned type. For example, in Java program language, we define the function will return some integer value, but it won't specify the name of the returned variable. This is the difference in Solidity. Now let's see the example here, the function return multiple. In the returns keyword, we have three types: integer, boolean, and array. So they are the types of variables returned by this function. So we can use keyword return to really give the value of variables back to the caller of the function. Remember that if we have multiple variables, you see here it's also allowed. The next thing is the named returned variables. This is the feature Solidity support. See this return named function in the returns keyword. Besides the types, we also give the variable names: underscore name, underscore bool, underscore array. In the function body, we don't need to explicitly use return keyword to give these variables back. Instead, we just need to assign the value to them. You can see this case: assign 2 to the number, false to boolean, and an array to underscore array variable. This is how we can return named variables in the function. Anyway, you can still use a very traditional way to return them by using the return keyword in such named return variables function. So this is how we can return variables or values in the function. The last feature I'd like to learn is destructuring. This is a feature that the modern JavaScript programming language also support. So if you are working with JavaScript, you must be very familiar with this concept. See the return named function. It gives us three variables, integer, boolean, and array, respectively. How can we access them? How can we receive them? So we define three variables: name, bool, array, and the return variables can be assigned to them. Remember that we need to use a parenthesis to wrap these three variables in the assignment. We also don't have to receive all of them. If we just interested in the boolean value, so look into this line of code, we can ignore the first and the third return the variables. Instead, we just need the second one. We declare a Boolean variable underscore bool2 to accept the Boolean variable. So this is how the structuring work. Feel free to do the remix experiment on Remix. You can find the sample example code here in the repo WTF-Solidity. I will put the link in the video description below. Feel free to check it out. So this is the function output. Now let's look into variable data storage and scope. Firstly, let's learn reference type. We have been talking about, or we have been learning the numeric types, the value types for a couple courses. Reference type include array, structure, and mapping. This type of variable usually takes up a lot of storage space. In the assignment, the address is passed. It's pretty similar to a pointer. This type of variable is more complicated, takes up, as I just said, a lot of storage space. So we must declare the location of the data storage when we are using it. There are three storage locations: storage, memory, and core data. Storage type of data stored on a chain. Memory and core data type of data or variables stored in the memory, which consume less gas than storage type data. The difference between memory and core data is that core data is pretty much similar as read-only. The core data variable is immutable. We can't change it. We can't mutate. See the example here. This is a function that we put core data on the parameter, function parameter, so we can access, but we can't mutate. If we try to change the first item in the array, we will see compilation error. Now let's see the data location and the assignment. When assigning a value or a storage variable to a local storage, which means in a function, a reference will be created. So storage variable assigned to storage variable. Reference will be created. This is what we call passing by reference. Similar mechanism as pointer. So changing the value of any reference variable, it will get affected in the other reference. So looking to this code, the example code, the X array is assigned to the other storage type variable X storage. So any change to one of them will affect the other one. This is a storage assignment. When we assigning the storage variable to a memory variable, it will create independent copies, which means in memory there will be a same copy of data as a storage variable. So modifying any one of them won't affect the other. It's the same. Assigning the memory variable to the other memory variable, it will create also reference. Changing that new variable will affect the other one. Now let's see the scope. Variables have different scopes: state, local, and global. State variable is a variable, the data stored on the chain, which can be accessed by all the functions in the contract. It will also consume gas. State variable are declared inside the contract, but outside the functions. They're pretty similar as the member variables of a class in object-oriented programming. And we can change the value of a state variable inside a function. You can see here, this example code. What is local variable? They are valid only during the function execution or in the context of a function. The data of the local variable stored in memory is not connected to the chain, so the gas consumption is relatively low. Normally, the local variables are declared inside a function. See the bar function declaration here. There are 3 local variables, xx, yy, and zz. Okay, the last type, global variables. These variables are all Solidity reserved keywords. They can be used directly without declaration inside the function. See the global function declaration here. In the body, we are using message block, these 2 keywords. They are reserved keywords and the global variables in Solidity. Check out the rest of the content here and learn more about those global variables and see how to use them. For more details, so check out the link here. There's a small link to learn more about special variables and functions. Okay, that's it for function output, variable data storage, and scope. Now let's go to Remix and try something. I just copied the data storage sample contract here and I put it in my Remix. So this is data storage code. Actually, there are 2 contracts you can see, data storage and the variables. Now let's deploy it. Actually, I have deployed before. Let me clear all the contracts and deploy again. So with a multiple contract source code, you can see here there are 2 contracts. So data storage and the variables. Now let me deploy data storage. You can see here there's an instance. Now I can call the function call data. Call data is here. As we are using call data keyword, so the _x variable is immutable, so we can't change. Now let's put some input here. We put 1, 2, 3. We pass 1, 2, 3 as parameter to the function. And let's see what it returns. If I click the button, you can see the same array returned. So this is what it does. So actually it does nothing but just return it. If I uncomment out this line of code, press Command S, try to modify the code. It gives me compilation error here, you can see. So this is how the call data keyword works. It won't allow us to mutate the data. So this is a function. Okay, let me show you another function, the fMemory. So this is a function that we are using memory type variable. If we click memory fMemory function button, if we call it, we don't see any effect. So let me try to return the arrays. All of these arrays are integer arrays. So I want to return 3 of them. I like to specify the storage all on memory. Now I can return x memory and x memory 2. Okay, this is fMemory. Let me compile and get deployed to see if it works. There's some error here. Oh, I need to comment out this line again. Now it works. Let me deploy. In the latest instance, I should be able to click the F memory and see the output. So X, this is a state variable. 1, 2, 3, the array stay the same. It's not changed. And memory X memory 100, 200. So the first two items of the array got changed, and the last element stayed the same. It's 3. X memory 2 got copied from state variable X. So originally it's of 1, 2, 3, and the first item got changed to 300. We expect 300, 2, and 3. So that's how the memory type variable works. And so this is the storage. Now I think we are ready for using different storage variables. So memory, core data, and state. Yeah, I think that's it for today. Thanks for watching. Hope you also learn the same knowledge. Yeah, if you feel it's useful, remember to thumbs up, subscribe to the channel, and ring that bell. Let's learn together online on WTF Academy. Okay, see you next time. Probably tomorrow we are going to learn reference types. That's it for today. See you. Have a good day. Bye bye.